If you have worked in a computer science class for any amount of time, you are familiar with a recursive formula or a recursive function. And what a recursive formula means is that you take the previous term and you do something to it to get the next term in the sequence. So we have a term, we do something to the first term to get the next term, and then we do the same thing to that term to get the next term, and then we do the same thing to that term to get the next term. And if this sounds familiar to you, it's because it's the same kind of idea that we used for arithmetic and geometric sequences. The difference is that recursive formulas are written a little bit differently. And here is an example of how a recursive formula is written. It's got a lot of the same parts as an arithmetic or geometric sequence does, except it often combines the two. An arithmetic sequence, we are adding or subtracting something every time. A geometric sequence, we are multiplying by something every time. A recursive formula could do one of these two things, but a recursive formula can also combine both multiplication and addition or subtraction. So let's look at the pieces of this recursive formula one at a time and talk about what they mean, and then we'll do what the question asks, which is to find the first five terms of the sequence. Now, this part you can probably get without me explaining anything. A sub 1 equals -8 means the first term is going to be -8. And then a sub n equals -2 times a sub n minus 1 plus 5. This is telling us what to do to get the next term in the sequence. This means do -2 times the previous term. That's what the a sub n minus 1 is the previous term. Then add 5. Now, this part on the end is not something that we're necessarily going to concern ourselves with, but it is something that needs to be included when we write our recursive functions. And it says for n greater than or equal to 2. This has to be included in a recursive formula when you write one, which we are going to do a little later. We're going to write recursive formulas. But all this means is we don't use this formula for the first term in the sequence. And the reason why is because we're given the first term in the sequence. That's what this a sub 1 means, is that's the first term. So greater than or equal to 2 just means we use the recursive formula, the -2 times a sub n minus 1 plus 5, for every term after the first one. So you have to include that when you write the formula, but all it means is don't use this for the first term, use it for all the rest of them. Okay, so we're going to find the first five terms in this sequence, and the first one's really easy. The problem gives it to us. It's -8. There we go. There's our first term. Now our second term is found by taking that first term, which is -8, and applying this -2 and plus 5 to it. So we're going to do -2 times -8 plus 5, and that's going to give us, well, -2 times -8 is 16, and 16 plus 5 is 21, so our second term is going to be 21. That's our second term. We're going to get our third term by doing -2 times 21 times our second term plus 5. So -2 times 21 is -42. And -42 plus 5 is -37. So our third term is -37. So our fourth term we find by taking that term, -37, multiplying by -2. Might need a calculator here in a minute. These numbers are starting to, whoops, these numbers are starting to get pretty big. Oh, lost my spot. There we go. Plus 5. Spoiler alert for what's coming next. -2 times -37 is +74, and +74 plus 5 is +79. There's our fourth term. And then finally our fifth term, -2 times +79, that's going to be a big number, plus 5. So -2 times 79 is -158, and -158 plus 5 is -150. 3. So our first 5 terms are -8, 21, -37, 79, and -153. Just like that. All right, let's try it again. First 5 terms of this sequence. Now we're starting with a negative here. -3 is going to be our first term. And this time we are multiplying by 4 and subtracting 9. Okay, so we're going to do 4 times -3 and then subtract 9. So 4 times -3 is -12, and -12 minus 9 is -21. Okay, so our next number is going to be -21. Okay, so then we'll do 4 times -21 minus 9. 4 times -21 is -84. And -84 minus 9 is -93. Oh, Lord have mercy. These are going to get to be quite big number. Well, small numbers because they're negative. Quite big small numbers. 4 times -93. Lord have mercy. All right, I'm getting a calculator for this one. All right, I'm going to cheat and use my calculator over here. So 4 times -93 is -372. And -372 minus 9 is -381. Whew, Lordy, that's the fourth term. All right, we got to do this one more time. 4 times -381 minus 9 is, back to the calculator, 4, oops, let me clear this out. 4 times -381. Whenever I clear my calculator, I just mash the clear button like 17 times. I'm pretty sure you only have to do it once, but just mash the clear button a whole bunch of times. I'm never quite sure. 4 times -381 minus 9 is -1,533. Whew. Okay. So our first 5 numbers are -3, -21, -93, -381, and -1,533. And those are the first 5 terms in this recursive sequence. So that's how you use a recursive formula. It's very similar to arithmetic and geometric sequences, except with a recursive formula, you can now combine multiplication and addition or multiplication and subtraction in the same sequence. And the equations look a little bit different. A recursive formula looks a little bit different than arithmetic and geometric, but they still have the same basic properties. We are told where you start, and we are told what you do with that starting number to get the next terms in the sequence.